The question reads as 14 kgs of an alloy having 20% iron or copper is mixed with 21 kgs of an alloy having 40% copper. Find the percentage of copper in the resulting alloy. So there's a mixture. We have just seen alligation, looks pretty easy. So let's try this by alligation. If I want to, so I know A1, one of them has 20% copper, the other has 40% copper. It is given to me that first one is 14 kgs and the second one is 21 kgs. But if you're smart, you should realize rather than using 14 and 21, what is more easier is the ratio, that is nothing but 2:3. 7 2s are 7 3s are 21. So that is going to be a more easier way to calculate. Let's see. And the question is asking us what is the resultant here. So remember now, this resultant average is asked. It's not given to us. However, since we are so fond of alligation, let's try using alligation out over here. So I have 20 and I have 40%. They all are in percentage, but I do not know the resultant here. What instead of them I know is, I know the actual weights or the ratio. So let me use the actual weights here. Now 14 kgs of the first one, 21 kgs of the second one. It would be wrong to say 20 minus something is 21. Remember, when we subtract, so let me take this for a minute as x, because this is what I want to find. When we subtract, this 20 minus x is not equal to 21, right? Or otherwise x minus 40, I write it on this side, x minus 40, this x minus 40 is not equal to 14. Remember, these numbers themselves can be very, very weirdish number, nothing related to the question. But what is important is the ratio. That ratio is going to be equal to the ratio of 14:21. So you can't assume this as 21. If you would have taken it as 21, you would have got x as 20 minus something is 21. So this has to be a minus 1. If this is a minus 1 minus 40 is not going to give us 14, right? So please don't take the actual value out over that. That is why I say if you are using alligation, you should be very perfect with the concept, what it is. The numbers are not important, the ratio is equal to ratio of the weights. That's about it. And rather than using this, as I have already mentioned, it's better to use this ratio. So still I do not get my x, and to solve this I would have to do some more pencil work. X minus 40 over 20 minus x is equal to 2 by 3. Now I can just cross multiply, that is will give me a 3x minus 120 is equal to a 40 minus 2x. That will result in 5x is equal to 160, is it? Yes, and x will be 32%. 32, so I've got my answer as 32. But this time alligation was not so very simple. Just subtract it and we get an answer. When after the subtraction I got terms in x, so I had to take then do the pencil work again here. Let's try this using the weighted average. Since it is asked, the weighted average is easy. The weighted average approach is going to be easier. Let's check it out. Oh, so 20%. We know everything is in percent, so we have done enough questions now. Into, rather than 14, I'll use the weights, 2, ratio of weights, plus 40 into 3 divided by the sum of weights. This is going to be my resultant average. Oh, so this 40 plus 120, 160 by 5, that's it. I've come directly to this equation by writing this, right? So, weighted average is easy. Hope now that you don't get stuck on any one approach. Either do every question by weighted average or do every question by alligation. Think about it, which is going to be useful. We will continue in the session. We'll do a few more questions solving alligation, and then at the end I will again show you a pitfall of using alligation. But before that, let's get used to a few more questions on alligation, because yes, in a lot of situations it is very easy, as the next question shows us. The question says, in a scheme of evaluation, there is a written test, there is practicals, and there is a project work, each having a different weightage. A student scores 60%, 70%, 80% in the written test. practicals and the project. The written test and practicals taken together, he scores 62%. The practical and the project taken together, he scores 76%. Find the percentage he scores if I consider the written test and the project work together. This is not a difficult question at all. This question, all it is doing is, it is making you practice alligation as well as weighted average thrice in the same question. So let's just quickly solve it. So we are given three components. So one of them is A1, which is given as 60%. The other one is A2, which is given as 70%, and A3, which is given as 80%. It's further given that the average of 1 and 2 together, average of 1 and 2 taken together is 62%. Now this is a classic case of alligation. Said I know A1, I know A2, I know the resultant average taken together, right? So I'll do the subtraction. 60 minus this is going to be a minus 2, 62 minus 70 is a minus 8. So what can I get from this? Remember, only the ratio is important. So the ratio of the weightages is nothing but 4:1 of the written test and the practicals, right? It is also given that average of 2 and 3 considered together, that is of practical and project together, is 76%. Again, a second situation of alligation. So quickly, 70 minus 76. The advantage of alligation is that you can do it so fast if this data is given in this form, if I know this, right? So this is a minus 4. Again, as we know, the ratio is important. The ratio of weight of the practical to weight of the project work is nothing but 2:3. And needless to say, practical is common to both of them, so I can find the ratio of weightage of all the three schemes of evaluation. Common, so I'll take that as 2. Since this is a 2, it will remain 3. W2 has become a 2, so W1 has to become 8. So this is the ratio of weightages. And the question is asked, what is the average of written and project considered together? So this time I want to find the average of 1 and 3. Since average is not given of the result, I want to find it. Weighted average is going to be much easier now. So that remains as 60 into 8. Remember, the percentage will be there all across, right? So I'm just ignoring that. Plus 80 into its weight, which will be 3, over the sum of weights. 8 plus 3, which is 480 plus 240 by 11. 48 and 24, 720 by 11, which is 11 6 are 66, 60 left over, 11 5 are 55, 5 by 11. This much percentage. If the answer is in decimal, we should know anything divided by 11. 9 5 are 45%. Hope this is clear. So we'll do one more practice example using alligation, but a little different. Till now, we were always finding the ratio of weights. Now, the ratio of weights will be given. One of A1 or A2 is not given. So, how does alligation make it easier then? Let's check it out. The question reads as, Article 1 is sold at 10% profit. At what profit percentage should Article 2 be sold such that an overall profit of 20% is made considering both the transactions taken together? It is also given that ratio of the cost price of Article 1 to that of Article 2 is 2:5. So there's Article 1, Article 2 considering overall. So weighted average concepts can be used. What is important here to understand is that overall profit percentage is given to us as 20%. Right? It is given. So we could possibly, this tells us that alligation is probably going to be easier, but alligation will appear a little different in this case. On the first article, I make a 10% profit. On the second article, I do not know what is the profit percentage, but yes, I know the overall, and if I know the average of the resultant, that is the two groups taken together, alligation will be better off. So since this is not known, I do know something else. I know that the ratio of weights is nothing but 2:5. I've already said this 10 minus 20 need not be this number. When we do 10 minus 20, I get a minus 10. It's not same as 5, but the ratio of these two numbers, whatever is here, has to be same as 2:5. So 10 minus 20 is minus 10. I can't do 20 minus this. No need of getting an x out over there, or else it will be as good as weighted average as such. If 5 part is minus 10, then 2 part has to be minus 4. And 20 minus a number has to be minus 4. If you can't make that out, so I'm writing it here, 20 minus a certain number has to be minus 4. So that number has to be equal to 24. So that's my answer. Right? So second article has to be sold at 24%. So we see that if I know the AR, even if I don't know one of A1 and A2, allegation still turns out to be, at least without a variable, we can solve it, right? So lastly, we are ending this session with one pitfall of allegation in the next example. The question reads as, I cover a total of 540 kilometers in 12 hours, partly at a speed of 40 kilometers per hour and rest of it at 60 kilometers per hour. Find the distances covered at the two different speeds. While it looks like a time speed distance question, you can form an equation and solve it that way also. You can also interpret the question as that of a weighted average. There's part of a journey at 40 kilometers per hour, remaining part at 60, and together overall I have covered 540 in 12 hours. So I could think of it as one part is at a speed of 40 kilometers per hour, second part at a speed of 60 kilometers per hour, and considering together, I know that I have covered a distance of 540 kilometers in a time of 12 hours. Since A1 and A2 refer to speeds, I can consider overall also as speed. So that is the resultant speed, or the average speed for this is going to be distance by time taken. 12 fours are 48, 60, 45 kilometers per hour. So now I have A1, A2, I have the resultant speed, so I can simply do alligation here very quickly. So 40, 60, the average is 45, so 40 minus 45, which is a minus 5, 45 minus 60, a minus 15. I've learned that ratio is important, so I've got the ratio as 3:1. Till now, I'm pretty sure everyone will be doing it, and it appears very easy as well. So where is the pitfall? The pitfall comes now. A lot of us are going to now, just because a question asks us, find the distances run at the individual speed, a lot of us are going to divide the distance. Divide the distance, which is 540, in ratio 3:1, because we have found the ratio 3:1, right? 3:1, so that is to be divided. This will go wrong, students. And the problem is in our interpretation of weights. So remember, if A1 and A2 represent speeds, then weight 1 and weight 2 represents time and not distance. This understanding can never be achieved by allegation. To understand this, we need to go back to weighted average, the format of weighted average. And if this is not clear, that means my session 1, I have not done it thoroughly well. So go back in the last 5-6 minutes of session 1, I've explained why it is time and why it is not distance, right? So it is, you need to understand that. If you are using allegation, you should have a thorough knowledge of what do weights refer to, right? So what does that mean? That means that we need to divide the time and not the distance. Though the question is about distance, let's divide the time, that is 12 hours is divided in 3:1. So that is the first time is going to be 9 hours. Time 2 is going to be 3 hours. And if I know time and this, I can easily find distance covered is speed of 40 into 9 hours, that is 360 kilometers. The distance covered in second part, speed is 60, hours is 3 hours, so that is 180 kilometers. You could add it up and see that total becomes 540. So hope you have got this. So allegation, while it is very easy, at least procedure wise it is very easy, but concept wise you need to be very sound in weighted average as such, right? So this winds up weighted average. Hope you have got this. Good luck with all the tests and the exercises that you have to practice post this.